Hello, hello, and welcome from sunny Barcelona. My name is Maciej Mazur. I'm leading the telco product team in Canonical. And today we wanted to invite you to show you a demonstration of how open source tools can help you to automate the deployment and day one and day two operations of your estate, especially in the context of open run deployments. So together with me, I have Arno van Huyssteen and Wajiha Hamid. Arno, would you like to introduce yourself?
Hi, my name is Arno van Huyssteen. I'm the CTO for global service provider at Canonical, and we essentially run a team that helps customers deal with the complexities being brought by the full container paradigm and virtualization, cloud infrastructure, open source products mainly, and all of the automation aspects of that to make their lives easier, to make the adoption faster, and to help them be successful within the telco space. We also have with us today Wajiha Hamid, who runs the product team from OSSM, and I'll let her say a few words as well.
Hello, I am Wajiha Hamid. I'm the product manager for open source Meno, and it's the management and orchestration layer for the telco networks overall.
Okay, so I think that we can start with the demonstration. Arno, would you like to walk us through the different components that we are using today?
Yes, sure. So what we're going to try and give you a brief look at is the way that we help customers deal with complexity in brownfield situations when the demands of virtualization has been met. So you've got clouds deployed, you've got the ability to bring up virtual machines. Either you've selected to do that on a bare metal cloud approach, or you have virtual machines via OpenStack. And what we bring today is the ability to meet that continued demand from your CNF vendors, so your complex workloads that come into the cloud to actually establish things like 5G cores, UPF functions, control plane functions, and policy control functions within the network, so within the mobile network, to then deliver service. And what we see happen quite frequently is that the CNF vendors, the VNF vendors that we have traditionally met in the field have a certain demand on the Kubernetes substrate or the container substrate that they would like to see deployed. In a lot of the cases, those vendors will come in with a demand to have their own approach to Kubernetes, their own approach to containers on the clouds that the customers would make available for those workloads to run on. And we feel that that ability for a mobile network operator to meet that need in a uniform way is really where we help them manage that incoming need, but also be able to give a substrate that has the right kind of parameters and technical capabilities so that you can deploy multiple workloads onto your cloud environments. In this specific use case, we're focusing on a number of partners. We're going to simulate or emulate the needs of 2 internal customers at a standard mobile network operator. Both of those network vendors will come in saying that they would like to deploy on their own Kubernetes cluster with some specificity in terms of CNIs and modular plugins. And what we are going to try and show here is the ability through tooling and automation, the standard tooling and automation that we use for cloud today, for NVI in telcos, and how we deal with that incoming demand on the teams responsible for that substrate, right? For Canonical, the NVI substrate is essential, or the substrate is essentially everything that is required to host a tenant-based workload. And in this case, if Kubernetes is the chosen container orchestration platform, which is by default and by de facto the most, I would say, popular container orchestration platform out there, we really want to help the customer reuse the tooling and automation that they've come to use to do infrastructure as code, and to get to the point where they can serve the incoming need. that incoming need might have certain demands from the tenant space workload side in terms of wanting to use either a CAS system like Rancher or Spectre Cloud, or a CI-driven pipeline approach by each one of the internal tenants. And that ability to meet both those needs, all of those needs, without having to change the underlying tooling and automation is really where the value is for the network operator. So what we show here in the demo today is essentially an incoming demand from, let's say, the mobility team, and an incoming demand from the voice team, both wanting Kubernetes options or deploy options for Kubernetes clusters, either on demand or triggered through some process. And we're going to show you these deployments into target edge or target bare metal environments located pretty far away. We've got a centralized component in this picture at the bottom that essentially emulates or simulates a tooling stack that a customer would then deploy to go and meet that demand. So the internal tenants would essentially be triggering the deployment of pre-modeled Kubernetes clusters from that centralized component. And whether you do it from Rancher, or you do it from a GitLab pipeline, or you do it from one of our partner products, Spectre Cloud, that is up to the internal tenant, right? Because they have a choice. Everyone has vendor relationships that they would like to maintain, and the ability to serve that vendor relationship even further. So what we then do is we enable through the use of, at the top you'll see two bare metal edge clouds. Those two clouds are actually located in Belgium, in a rack. And what we're simulating is the ability for the internal needs for tenant A and tenant B to be served through a construct called resource pools in MAZ. So MAZ is a bare metal orchestration capability, open source product from Canonical, which we deploy as a standard part of our infrastructure story. And it gives you the ability to do a whole host of things. It discovers hardware, it pulls all of that information, all of that specificity of the hardware into a database, which is then addressable through an API. And you can make decisions based on a number of the capabilities that was discovered during the discovery process to then deploy either operating systems, whether it's Ubuntu, ESXi, Red Hat, onto that target environment. Now, in this specific case, we're going to focus on a use case in which the edge is essentially a shared edge. Everyone talks about edge today as a bare metal capability for use case 1. And unfortunately, thinking about use case 2 and use case 3 is too complex at this stage, because everyone is trying to deal with that first use case. But in reality, in a brownfield situation, you will have multiple internal requirements towards an edge type deployment. And edge can be a highly distributed compute pools throughout your network to manage things like user plane functions for 5G, or it could be required for your Open RAN play. Depending on your internal needs, you will have to have a strategy to deal with that complexity. So in this case, we're splitting the edges. So edge site 1 and edge site 2 are both 10 node clusters in a remote data center within Belgium, in a lab that Canonical owns. And the centralized site is right behind me. I don't know if that's visible on that box. That also contains 10 compute. Let me show it again. On that server at the back there. So the server at the back hosts a number of components, what we call a GitLab instance that is deployed and supported by Canonical. If you could bring up the slide again. So it contains a number of instances, tooling instances that is common and reusable for the internal tenants. You have a Rancher instance there, open source Rancher deployed on a microcades cluster, which will essentially give you a supported Rancher capability for visibility into CNCF compliant Kubernetes clusters when deployed. It has a GitLab instance, like I said before, for the internal tenant that would like to deploy through a CI pipeline-driven method, pre-modeled Kubernetes onto edges. In that instance, we also have an on-prem deployment of a partner CAS system called Spectre Cloud, which is a fairly innovative product, and we have recently announced partnerships with that vendor. And they will be, what we'll do is we'll show the ability to deploy from both Spectre Cloud and that GitLab instance from 2 different internal users. And when they reach the MAS edges, edge site 1 and edge site 2, you will see that user 1 will only see tenant A's hardware pool, and tenant B will only see resources from that tenant that was allocated by MAS. We use a product called Candid to get RBAC functionality within the MAS. And then through the way that Juju logs into that edge to deploy the environment, we then instantiate the clusters. Once those clusters stand up, they use a mechanism that is inherently built into the automation framework, the Juju automation framework, to cross-model relate the complexity in the Kubernetes model or the deployment in Kubernetes model 1 into a number of different environments, including a logging, monitoring, alerting stack that is centrally located, also registers that cluster for the tenant deploying through Rancher or deploying through a CI pipeline into a Rancher instance, and the same for the Spectre Cloud deployments. The Spectre Cloud deployments is essentially a little bit easier because the products were built using MAS and Juju functionality and technology as the base, and therefore it is more seamless. It is a really extensive UI that allows you to do a number of modeling events in a very UI-driven manner, but then to trigger the deployment of that modeled environment into target edges or into target environments, either on a very granular level or on a very wide level. So either the entire estate or a smaller estate. So on the left-hand side, you're going to see an environment called Jazz, that's Juju as a service. It is a UI specifically used for large at-scale deployments that where you would have multiple clouds, multiple cloud targets, multiple MAS instances, both on-prem environments and cloud environments in AWS, Google Cloud, and Azure, but also multiple other types of environments. The reason we use this UI is to give the infrastructure team within the company a centralized view on all of the estate within the company. And that is really important when it comes down to the supportability of on-demand Kubernetes within a customer like telco, right? On the right-hand side, we've got, let me just see what that is. Yeah, so this is a Spectre Cloud UI in which you see a number of graphs depicting Kubernetes that have been deployed before. I'm really sorry, the UI is very small on my screen. So what we're going to do next is deploy a Kubernetes instance. And we're going to use a CI-driven method from team 1 or tenant 1 to deploy into resources allocated to that tenant in both the 2 edge sites or one of the 2 edge sites using that MAS resource pool construct to ensure that that tenant only sees bare metal assigned to them. Now, the use case in that case, while the demo is ongoing, while the pipeline is deploying that Kubernetes cluster for us, what we're going to talk about is it could be that day 1 you start off with 3 or 5 nodes within that edge pod, right? Within each edge pod or bare metal cloud that you deploy. But over time, you might get demands for AI/ML use cases or video stream processing, where you might need some GPUs in certain nodes, or you might have very specific hardware for different types of use cases, also needing a place to live in the edge. And what MAS is capable of is discovering those additional components being plugged into that edge pod, taking that specificity, all of the SKU information, all of the technical information for those newly discovered machines into the database, and then giving you the ability to address that through every time it discovers a certain type of machine to tag it in a specific way, so that when you deal with the complexity of deploying complex software onto multiple targets of bare metal clouds, that you can actually tag and specify a tag to be used. So if you need a machine that has specifically got GPU capabilities, then obviously you'll tag it within the automation framework that puts down that complex piece of software. And what you're seeing on the screen right now is a live deployment from Barcelona, Mobile World Congress Room in Barcelona, that centralized tooling stack that we just showed you, into an edge that is located in Belgium, in Iraq. I don't think we have a video stream today, but it's quite fun to see the NUCs all powered off. So the compute modules all powered off, then being powered on, commissioned, and then for Juju to take over to actually speak to Maz to get the right kind of machines so that it can actually deploy a Kubernetes cluster. Now on this screen, you see that there is obviously a user that was used to log into Maz, and this user can only see a number of nodes. Whereas if you look at so nodes 1, 3, 4, and 9 is visible on the left-hand side, whereas nodes 6, 7, 8, and 10 is visible on the right-hand side. So user 1, tenant 1 was logged in into that Maz edge pod on the left-hand side, and tenant 2 was logged in on the right-hand side. And those two tenants cannot see each other's hardware, right? The hardware is essentially invisible for them and cannot be consumed. So if you have noisy neighbor kind of problems, or you want multi-tenancy within your edge pods, then obviously you want to be able to deploy using these RBAC mechanisms, these resource pool mechanisms within Maz. Maz is extremely capable in the ability to stand up machines for multiple types of workloads, even if the demand is, unfortunately, some people still require non-Ubuntu based machines. But if you absolutely need non-Ubuntu based machines, we can deploy ESXi, like I said, Red Hat and other OSs on that target blade or that permissioned machine, so that you can put down the workload that you're trying to deploy. Now, this is standing up a Kubernetes instance. Obviously, once that Kubernetes instance is up, you will see it appear within I would say, the infrastructure team's view within Jazz and Jim. What this gives you the ability to do is manage, from an infrastructure perspective, all of these on-demand Kubernetes clusters standing up all over your network. So your internal team A, tenant A, and tenant B are continuously deploying on-demand Kubernetes in their own fashion. So one using the Spectre Cloud UI, and the other one using a GitLab instance. But the infrastructure team will have a holistic view on the entire infrastructure, so the entire estate, all of the Kubernetes that are standing up, all of the Kubernetes components that is actually consuming resources within that environment. On the left-hand side top there, you see a little bit of a graphical representation of the model being deployed, all of the modules within that Kubernetes cluster. Then you have a list view, which once deployed will show you things like statuses, versions, the amount of units of each one of those components that you have within the model that you've predefined. And I say model a lot because it is modular, right? So you can remove the CNI in model 1 and replace that by a different CNI if your vendor requires that. And in your second modeled Kubernetes, you can define a completely different CNI and set it up with the specific needs of that second workload, right? So that when you see it on this screen, this is the infrastructure screen view. The infrastructure team will log in here, and they will be able to assist that internal tenant A or B if something goes wrong during the deployment cycle, or there's an issue with the cluster and they think that cluster might be faulty, right? Currently, the statuses are all alert. They are busy deploying. At the bottom, you can see a CLI view of that graphic at the top, and it essentially shows you the Juju status view you can see in a customer. What we usually do, and it's nice when it colors the bottom, so Juju color status message, so that you can see the components and in which states they are and how many units are deploying in which type of machines. Are they deploying into LXD cluster or KVM machines or whatever the model is defined. But once this is up, it actually becomes an operational tool, right? So that operational tool will tell you, are there any units in an incorrect state, in an error or a fault state? You could click on that unit. You can see subunits deployed within the model. You can actually CLI to that unit in real time to try and troubleshoot that problem, to look at logs, to do a number of activities. And within this version, you will also see every conceivable action that the charms, the automation framework, has exposed for instance, in Kubernetes' case, lifecycle management events. You want to add a node, you want to take a node away, you want to upgrade that environment. All of the capabilities that is actually exposed in a Pythonic, in an operations-driven way, is contained and can be triggered from this UI. So this cluster will take a little bit of time to do. Maybe we should kick off the deployment through the Spectre Cloud demo as well. So in this, on the right-hand side, you will see tenant B trying to deploy a Kubernetes cluster to the same edge pod targets as we had before. So those bare metal clouds in Belgium. And what we're going to do is we will go through a structured, very intuitive way to define the needs of that cluster. If you go back one step, just step 2 there, I just want to show the audience. So within Spectre Cloud, because they use Maz and Juju as the base automation layer, you have native capability out of Juju that will give you the ability to target substrates, whether they are public cloud or private cloud, whether they are OpenStacks or Mazes. And you'll see that selection capability in the middle there with AWS, Azure, your edge kind of constructs all defined for you, easy to select. It's a UI-driven approach to define essentially what we did on the left-hand side in a YAML model and put into a CI pipeline on the right-hand side is being done in a UI fashion. That model, once we have defined it, so we're going through a number of steps here, making a couple of selections in terms of the operating system we would like to have to see deployed. Obviously, it says 1804 there, but we can go to 2004 LTS or even 2204's beta version if you wanted that, and then deploy that. And I think for the audience, there is an announcement coming in 2204 LTS, a partnership we've been working on for quite some time. That is fairly hot off the press, I would say, in terms of us enabling feature sets and capabilities within Ubuntu that has been demanded by telcos for quite some time in relation to RAN deployments from some of our silicon partners. So the SDKs that exist today for Open RAN deployments, those kind of announcements you will see coming out from April when we announce 2204 LTS, and from our partners in 2206, so June approximately. So in this screen, we're selecting a number of options, including the CNI that we would like to see deployed. We're giving the cluster some target information, like which edge pod you want to go into. And again, you can specify very granularly whether you want to go into a specific edge pod or whether you want to go into all of the edges or a region's edge pods or bare metal cloud targets, or your entire estate, all of the edge sites that you've deployed on your 90,000 cell tower sites or your 20,000 cell tower sites, right? Complexity abstracted through model-driven operations enables you to be able to deal with that highly distributed nature of edge in a very easy and intuitive way. So we're going to continue defining a number of items here. Resource pool use. That resource pool use is obviously the things we've defined for the Maz part, and it'll take into account all of the capabilities and the resources available to that user when triggering the deployment into that. So here you see a very nice graphical way to look at the different layers you've defined there, and you get one last chance to say yes or no. Obviously, there's a number of safety mechanisms for in case you made a couple of wrong choices there, and you can go back and redefine it. You can save this model, and you can, like I said, deploy this onto multiple edges, multiple targets. I don't know if we have a view on the edge we're deploying on at the moment. Juju status color for that. This is the Maz UI. We're seeing those machines are all off at the moment. And hopefully, we're going to see those machines, so Maz being triggered to bring those machines online, commission them with an operating system, and then doing the necessary interaction between Spectre Cloud's UI, using, again, Juju and Maz and then deploying those environments on that edge target. Yeah, it's going to take a while. So maybe we can quickly switch to Wajia and have a quick think about how we could leverage OSM's capabilities within the ecosystem and within the VNF placement and orchestration.
Perfect. Thanks, Arno. So open source menu, just a little introduction, like it's open source community-driven project. It's which lies at the top of the telco networks. As telco networks are complex, so there is a need for their management and orchestration. So OSM is basically an HC-aligned project, which is there to orchestrate telco network services. So if you are going to deploy your telco networks in the form of virtualized and containerized workloads, then you can deploy them in multi-cloud and hybrid environments. So there are a lot of orchestration tools out there, but to avoid the vendor lock-in, OSM can help with vendor-agnostic environments. Like you can bring up your workloads in any environment like OpenStack, VMware, or in any public cloud like AWS and Azure with some same YAML descriptors, which can be understood by OSM. That has actually made possible by having using standards in OSM and the generic virtual network function manager, that is Juju, as discussed by Arno before. Then other than that, we have our own distribution, that is Charmed OSM, where we have actually reduced complexity. And we are here in MWC to present actual 5G workloads deployment using OSM with full automation and with full lifecycle management of these 5G telco workloads, specifically a PCF. So if you really want to talk about the OSM capabilities a little bit, so it offers the management at the infrastructure level, so that network functions you are trying to onboard have the required number of resources available. It actually also helps in the onboarding, that is day 1 and day 2 operations, and manages after onboarding for the scaling and business continuity of these 5G workloads. So here in MWC Barcelona, we are seeing so much demand for private mobile networks and orchestration for those open source private tools, and we think OSM is the right choice for that right now. And Maciej, do we want to do that? Okay.
Yeah, welcome. So I basically wanted to let you know also about the other interesting things happening in MWC, which include Ubuntu and Canonical technology in general, all the open source projects that we do. And I'm especially proud of the thing that we did together with Vodafone, which is basically a cloud smartphone. They are presenting that on their booth. Really nice demonstration. If you are in Barcelona, I would ask you to try to see that. But basically, just to give you a gist of what that is. So it's using Unbox Cloud, the project that allows you to run Android on a LXD container, which is at the edge. So what it means that you can basically take a super cheap device, which is just a screen, a battery, and a 5G radio, and that is just showing you the screen that is actually running on the Android, which is emulated at the edge in the LXD cluster. So what it means that you get the stream, you can work with it like with a normal phone and have all the advanced features enabled, because the edge where the actual compute is running is equipped with a powerful hardware. The demo that we have set up is actually running like an Ampere Ultra server together with powerful GPUs, and it's well accelerated, so you can play latest games or run really intensive workloads. And what you can also do, which is really nice, is basically work like in some science fiction movies that you could watch recently. So if you enter a cab and work on your phone, for example, and do something there, you can just scan a QR code on a screen that is in your Uber or on a screen which is in a shopping mall, and then move the stream that you got from the Unbox to your device, move it to that screen, and you can continue working. And when you move out from the area or you get out from the cab, all your data and everything is coming together with you, because actually there is no data on the device. Everything is streamed from the edge. So that's one of the more interesting things that we are doing. And now I think we can get back to Arno.
Yes, hi. So we're back. While those clusters are deploying, what we're showing on the screen now is deployed clusters we did a little bit earlier on one of those edge targets. Same construct, one tenant deploying using one methodology, same tooling and consistency in the sub layers, and a second tenant deploying into that environment. And what we did there was we used the functionality within Juju to relate a complex model of software, in this case Kubernetes, to another complex model of software. On the left-hand side there, a model of a logging, monitoring, and alerting stack, so that once that Kubernetes model stood up, once it became active and all of the units were deployed, that it actually reached out to that logging, monitoring, alerting stack. They exchanged some information, and that information got used to actually go and configure that Kubernetes as a newly deployed Kubernetes target that is now ready for workloads within the monitoring stack, within either the NOC or within the monitoring facility for the mobility team or the team used to deploy that Kubernetes cluster on demand. Now that capability is something we use fairly extensively within Canonical, and you will see more in-depth telco use of that functionality coming out soon. We're close to releasing our Chant Magma product, and that product will enable us to help customers who want to stand up factory mobile private network use cases with radio partners, where you define within models the complexity of the radio deployment, all of the functionality onto target substrates, but also the complexity of the core that you would like to run that network with. Once you've defined the models for both of those, you stand both of those units up and you cross-model relate them. They'll exchange information, settings, and they will essentially bring up an entire network at the touch of a button. That is an on-demand mobile private network product that Canonical is using all of the same tooling that we use in infrastructure to commoditize that consumption of infrastructure, both OpenStack, Kubernetes, bare metal Kubernetes, and other products for telcos on. Additionally, a partner of ours has also done some fantastic work to automate the deployment of the OMEC 5G core, and we plan to extend that work in the ONF community as well by adding more automation. We have engineering teams focused on the automation of those components. So they'll become consumable. They will also be able to, you'll also be able to define in those models the ability to cross-model relate those type of deployments into things like a logging, monitoring, alerting stack for that capability then to just automatically show up. On the right-hand side, what we tried to do there was show you that one of your tenants prefers the use of a Rancher cluster, upstream open source Rancher deployed on a microcades cluster, so a snap deployed Kubernetes that is fully resilient. I think micro in that product name is a little misleading because you can deploy a microcades cluster up to hundreds of nodes, and they will form a seamless cluster, right? On the right-hand side, again, Rancher deployed onto microcades cluster. And what happened there was for that Kubernetes that we deployed into the edge locations, they reached out to Rancher. They grabbed credentials and they registered themselves into that Rancher cluster in an automated way so that they would also just show up within the Rancher cluster. So now if multiple Kuberneteses are deployed onto multiple edge target sites, that team that needed those Kubernetes stood up, have the immediate capability to look at that environment, start managing that CNCF compliant Kubernetes by doing what they used to call pod security policies, but configuring that environment, managing it, looking at it from a user perspective of Kubernetes. Whereas the Jazz you saw earlier was more an infrastructure type of view of the same environments with more capabilities and tools that will help the infrastructure teams manage that complexity of internal customers demanding additional Kubernetes clusters. And I think what we're showing on the board now is that stood up Kubernetes. I think for today, that brings us to the end of it. There's a lot of different technologies that we've spoken about today, a lot of different terminology used here. I think there's a mix of both telecommunications constructs and all of the product line that we have at Canonical. We serve telco customers, service provider customers, by helping them adopt automation and infrastructure-driven code approaches to make them more successful and make their life easier, essentially. And we do that in many different ways. Automation is one of them. We feel that customer service providers will also consume a number of open source products like Kafka and Grafana and a number of other tools that they might pick up on open source communities. For those type of customers, Canonical has a strong focus on security. We have an extensively big security team, and that team focuses on not only on the infrastructure part of the stack, so the software stack needed to stand up an infrastructure, but also if you want to consume applications from an open source destination, we will back off the support into those locations. We will CVE patch those, and we will make it available to our customers in a secure fashion. So that whatever you use out of the open source community, Canonical will commit to support you in making sure that that application is as secure as the rest of the infrastructure you've stood up. If you chose to go with a CIS hardened cloud, a FIPS compliant cloud, or any one of a number of certifications, right? So I'll hand over back to Maciej. Thank you very much, and have a great MWC. If you do get a chance, please do check out that Vodafone demo at the booth. It is, I would say, a more advanced use case for 5G radio. It is an alternative view on the use of technology. We see it going into markets where we could help customers make sure that the spend they do, the CapEx spend they do, actually generates ROI faster by accelerating 5G adoption through the ability to use non-subsidized handsets, really low-cost devices, but give the same user-level experience on a edge-based solution for that emulated product. Maciej?
Yeah, thank you all very much for joining today, and please take a look at our social media. From time to time, we'll be posting more announcements during the MWC, and also with the coming months, as Arno said, next release of Ubuntu 22.04 is going to be really big in telco context. So stay tuned, visit our website at ubuntu.com/telco, and have a lovely end of the day.